Welcome YouTubers to another episode of my Grammar Hero series. In this video, I'm going to be working out practice problems from the arithmetic reasoning section of the ASVAB. Before I do that, I just want to take a few minutes to make some general comments about the ASVAB itself. First, I want to point out that the ASVAB is comprised of 10 different subsections, including general science, arithmetic reasoning, word knowledge, paragraph comprehension, and so on. As you can see, the length varies, as does the time length or time limit for each section. Since we're talking about arithmetic reasoning today, I more specifically want to point out that on test day, you'll have 39 minutes to complete 16 questions. Okay? And of all the sections in the ASVAB, you're given the most amount of time to do this one. Okay? What's more, I also want to stress that there are a few sections you want to do especially well on. The arithmetic reasoning section, the word knowledge section, the math knowledge section, and the paragraph comprehension section, all of these subtests form what's called your AFQT score. That is your Armed Forces Qualification Test score. That, in other words, is the score that says, yes, this person's qualified to join the military, or no, this person's not qualified to join the military. In addition, your AFQT score is typically what opens up different career paths to you in the military. The higher you score in terms of your AFQT score, the more jobs that become available to you. As a rule of thumb, you want to try to score in the third category or higher. So in essence, these three composite scores are going to be added together in some formula, and you're going to be given a percentile rank. For example, if your AFQT test score was 65, that means you scored better than 65% of all the test takers. Okay? I just want to take another minute to point out that practice makes perfect for this test. As a rule of thumb, I would say you should take at least 10 full-length practice tests before you take the real ASVAB. And again, I would devote 100% of your studying efforts to focusing on these four sections rather than looking at electronics information or anything else. Okay? Because again, if you get a good AFQT score, everything else will fall into place. Okay? Just a reminder, there's no calculator on the ASVAB at all, and that's not surprising given that this is the arithmetic reasoning section. This section is testing your ability to use some basic reasoning skills to set up your arithmetic problems. Okay? So if you're rusty with division, multiplication, and fractions, now's your time to pay close attention. I'm going to work out these 16 problems as slowly as I can. Okay? So that said, let's go ahead and get started. Question 1. A car headed west for north plot left at the same time a car headed east left the same place. The car headed west traveled at 55 miles per hour. The car headed east traveled at 70 miles per hour. How many miles apart were the cars at the end of 2.5 hours? Before I set this problem up, I'm going to say any problems involving distance times rate times time, or distance equals rate times time, you're going to see these problems on the ASVAB. You're going to see several of them. So I believe in this presentation I'm going to have 3 of them. Pay close attention to these problems. You will see them on test day. Guaranteed. So again, as far as this problem goes, we have 2 cars starting at the same spot. One's heading east, which is this way. One's heading west, which is this way. We know this car is traveling at 55 miles per hour, whereas this car is traveling at 70 miles per hour. question is, how far apart were they after 2.5 hours? Okay? This formula says distance equals rate times time. I just want to point something out to you. We're talking about miles per hour, so our time is always going to be in hours. In other videos, I did problems where the time was in minutes. You need to convert minutes to hours or fractions of hours whenever you get DRT problems. Okay? Fortunately enough, this one's in hours, so we can proceed. The trick to this problem is to think about it this way. Imagine you had one car traveling this distance, just one direction, albeit at a combined rate of 55 plus 70 miles per hour. Okay? And I'll do that math in case you guys don't know what that is. 7, 8, 9, 10, 11, 12. So imagine if you had one car heading in one direction at 125 miles an hour for 2.5 hours. That's the same problem, okay? You're going to travel the same distance whether it's two cars heading in opposite directions at different speeds or one car heading in one direction at one speed. Okay, so that said, let's go ahead and plug in numbers to our equation and see what we come up with. So we don't know how far we're traveling, so we're going to leave distance in our D equal RT formula blank. We know we're traveling either at a 55 plus 70 miles per hour or 125 miles per hour combined. And for a total of 2.5 hours. Okay, so this just becomes a simple multiplication problem. 125 times 2.5. When we're multiplying fractions, it's easier to make them whole numbers and add the decimals in at the end. So we're going to take this 2.5, move it over here. We moved it one spot to make 2.5 25. At the end, we're going to add one decimal into the left. Okay, so 5 times 5 is 25. Carry the 2. 5 times 2 is 10, plus 2 is 12. Carry the 1. 5 times 1 is 5, plus 1 is 6. Bring down a 0 since we're starting a new row. 5 times 2 is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 1 is just 2. 5 plus 0 is 5. 5 plus 2 is 2. 6 plus 5 is 11. Carry the 1. 2 plus 1 is 3. Bring our decimal back in. And we can see that that's going to be a distance of 312.5 miles. Okay, so that's that one. If in another problem you had the cars traveling toward each other at a specified distance and it said how long before they meet, you would think of it the same way. That is, you combine their speeds, and in that case you'd be finding the time, not the distance. Okay, Joshua has a jar with 12 marbles. The jar contains twice as many red marbles as yellow marbles, 3 times as many green marbles as yellow marbles, and twice as many purple marbles as red marbles. How many yellow marbles are in the jar? So since all the other marbles seem to reference the yellow marbles, I'm going to let the yellow marbles be represented by X. Which I can then say is there are twice as many red marbles as yellow marbles, so I can say red marbles is 2x. There are 3 times as many green as yellow, so I can say the number of green marbles can be represented as 3x. And then there are twice as many purple as there are red, so I can say purple is twice of red, which I can represent as 4x. Okay, I want to know how many yellow there are out of 100, so I'm going to set up an equation that looks like this. X plus 2x plus 3x plus 4x equals 100. Combine our like terms. X plus 2x is 3x plus 3x is 6x, plus 4x is 10x. So we're given 10x equals 100. Divide both sides by 10. This cancels. 100 divided by 10 is just 10. Again, we said yellow is just going to be represented by x. X is 10, so we know there are 10 yellow marbles. Mac travels 1,100 miles during a 40-hour work week. If he spends 2/5 of his time traveling, how many hours does he spend traveling? This is not a D equals RT problem. It's not a distance rate time problem. We're told he works 40 hours a week, and he spends a proportion of that, specifically 2/5, traveling. So in other words, we want to know what 40 times 2/5 is. We can think of 40 as 40 over 1. So we just, when we're multiplying fractions, we multiply straight across and then reduce. 40 times 2 is going to be 80. 5 times 1, of course, is 5. Now we have 80 divided by 5. Let me show you the long division in case you forgot how to do this, or you don't know, or it's not obvious to you. 5 goes into 8 one time without going over, so 5 times 1 is 5, subtract it out. 8 minus 5 is 3, bring down this 0. 5 goes into 30 6 times. So he spent 16 hours of his work week traveling. Okay? A teacher deposited $3,000 in a retirement fund. If she didn't add any more money to the fund, which earns an annual interest rate of 6%, how much money would she have in a year? So basically her funds earned her 6% a year. So that's going to look like this. 3,000 times 0.06. Okay? And again, when we're talking about percents, we have to be able to convert percents to fractions to decimals and vice versa. In this case, we would represent 0.06 like this. 6 over 100, which is the same as 0.06, which is the same as just 6%. So you got to be able to think about decimals, fractions, and percents in the same way. You have to be able to convert from one to the other fairly easily. Okay? Again, we're multiplying a decimal to make this math simpler. I'm going to move this over here. So this, in other words, is going to become this. 3,000 times 6. And again, I moved my decimal place twice. So at the end of this math, I'm going to add 2 decimal places back into the left. So 0 times 6 is 0, 0 times 6 is 0, 0 times 6 is 0, 0 times 6 is 18. Add our 2 decimal places back in, 1, 2. So after a year, the account has accrued $180 in interest. We take 180 and add it to 3,000 to get our total amount in the account after a year. It's going to be 0 plus 0, 0, 0 plus 8 is 8, 0 plus 1 is 1, and 3 plus 0, of course, is 3. So after a year, there should be a total of $3,180 in the account. A farmer constructs a wooden bin. The bin is 6 feet long, 4 feet wide, and 3 feet deep. The bin rests on legs that are 3.5 feet tall to keep grain away from the damp ground. How much grain can the farmer store in his new bin? So a bin is basically a cube. Let me go ahead and sketch one of those out real roughly for you. And if you take a look at our answer here, we're talking about cubic feet, so we know we're going to be working with volume. The volume of a cube or a rectangle is going to be this. Volume equals length times width times height. If it was a cube, it would simply be one side cubed. But since all these sides are different, we do length times width times height. We know it's 6 feet long, 3 feet deep or 3 feet tall, and 4 feet wide. Okay, and we know it's sitting on these legs that's irrelevant. The information about the legs is extraneous information. So let's go ahead and plug these numbers into our volume equation. We know the length is 6, the volume is, or the width is 4, and the height is 3. Let's keep working that out. This becomes 12 times 6. And in case you don't know your times tables for 12s, let's work that out. 6 times 2 is going to be 12. Carry the 1. 6 times 1 is 6, plus 1 is 72. So the volume is going to be 72 feet cubed, or 72 cubic feet. Denise buys a soda for 90 cents, a candy bar for $1.20, and a bag of chips for $2.90. Assuming there a 3.5 sales tax, how much change would she receive from a $10 bill? Okay, so let's go ahead and total up how much she spent. We know she spent $2.90 plus $1.20 plus 90 on the food itself, excluding tax. 0 plus 0 plus 0 is 0. 9 plus 9 is 18, plus 2 is 20. Carry the 2. Bring down the decimal. 2 plus 1 is 3, plus 2 is 5. So on the food alone, she spent $5 excluding tax. We know this, since it's $4.82, is wrong. It's less than 5. Okay, let's find out how much she spent on tax. Let's do 5 times 3.5. And again, I'm going to move this decimal one place to the left, or to the right. At the end, I'm going to move it back in. So 25, or 5 times 5 is 25. Carry the 2. 5 times 3 is 15, plus 2 is 15, 16, 17. And I actually made a mistake. 3.5% is actually 0.035. So to get this to 35, I had to move it 1, 2, 3 decimal places. So disregard this 1 that I said. We moved it 3 decimal places to make 0.035 to 35. Let's add those 3 back in. 1, 2, 3. So we know she spent 17 cents and a half, or 18 cents on tax. So 17.5 or 17.5 cents is rounded up to 18 cents. So in total, she spent $5.18, including tax, for food. How much change will she get back from a $10 bill? Let's go ahead and do the subtraction. Some of you could probably do this without working it out. That's great. We have 8 minus 0 and 1 minus 0. We know we can't take anything away from 0. So I'm going to make this a 9. And I'm going to bring this. This is going to become a 10. So now I can do 10 minus 1, but I still can't do 0 minus 8. Let me make this a 9. And I'm going to make this a 10 now. Always keep your decimal place in the same spot. So 10 minus 8 is 2. 9 minus 1 is 8. 9 minus 5 is 4. So she's going to get back 482, which is the one I crossed out, it turns out. My mistake on that, I wasn't thinking when I said this, so disregard. It's going to be 482. If it costs $5.50 per square foot to build a new patio, how much would it cost to build a patio that's 9 by 20 feet? So a patio can be a square or a rectangle. In this case, it's a rectangle. It's 9 feet wide by 20 feet long. Costs $5.50 per square foot. So we need to find the area of this and then multiply by square foot. Area of a rectangle is simply length times width. We have 20 times 9, so let's plug that in. We know the length is 20, the width is 9. So 20 times 9, let's work that out. That's 0, 18. So we know this whole thing is 180 feet squared. We know it costs $5.50 per square feet or square foot. So let's take 550 and multiply it by 180 to determine how much we would spend to build the new patio. Again, we're going to move this 2 decimal places to the right, and we'll add those back in at the end. We got to be careful now because we're multiplying 3 digits by 3 digits. This can get very tedious. So let's take our time. 0 times 0 is 0. 0 times 5 is 0. 0 times 5 is 0. We drop down a 0 since we're starting the second digit. 0 times 8 is 0. 5 times 8 is 40. Carry the 4. 5 times 8 is 40 plus 4. That's 44. Starting a new row, so we drop down 2 more zeros, especially since we're on the 2 digits. Again, second digit, 1 0. Third digit, 2 zeros before you do anything. 1 times 0 is 0. 1 times 5 is 5. 1 times 5 is 5. Let's add everything up. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 0 plus 4 plus 0 is 4. 5 plus 4 is 9. 5 plus 4 is 9. Okay? We took 2 decimals away. Let's add them back in. 1, 2. So we know... Oh! What did I do wrong here? I made a mistake here. Answer should be 990. I made another math mistake. Let's see what I've done. It was right here. This would probably be a 0. So let's think about it. 8 times 0 is 0. 8 times 5 is 40. Okay. Which I put. 8 times 5 is 40 plus 4, which is 44. Let's see what I did wrong here. 550 times 180. Again, guys, I do make mistakes. This is proof of that. 0 times 0 is 0. 0 times 5 is 0. 5 times 0 is 0. Drop down a 0 since we're starting the second digit. Again, 2 decimal places. 8 times 0 is 0. 8 times 5 is 40. Carry the 4. 8 times 5 is 40. Add 4. That's 44. You can see my mistake. This should have been a 0, not a 4. Okay, let's work the final row. We're going to drop down 2 zeros since we're starting the third digit. 1 times 0 is 0. 1 times 5 is 5. 1 times 5 is 5. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. This is going to be 9 and 9. Let's add those 2 decimals back in. So this is going to be $990. Okay. When you multiply 3 digits by 3 digits, you're prone to make mistakes. If you ever make a mistake like this, always just redo the math. You already did the hard part here, and this is fairly obviously correct. This is where you make the mistake, so you would just have to simply pull it to the side and try it again. And you will experience that on test day. You will make at least one mental mistake. Okay, a road map is drawn on the scale of 1 inch equals 10 miles. When planning your trip, you notice that you'll have to travel 10 inches on the map to the first turn, 7 inches to the second turn, and then 15 inches to your destination. Your car gets 28 miles per gallon, and gas costs $2.73 per gallon. How much gas money will you need to spend for round trip? Whenever you hear miles per gallon, always think miles divided by gallon. And you'll see why in just a minute. But but whenever you hear how much does it cost per gallon or miles per gallon, always think miles divided by gallon. You'll never go wrong if that immediately pops into your head. So let's do a little sketch. You start here. You go 10 miles to your first turn. Let's say you make a turn to the right. You go 7 more miles to your second turn. Then you go 15 miles to get to your destination. And then you make the round trip, which is basically the same way back. So we're going to have to double this. We know 1 mile represents 10 miles according to our scale. So in total we went 17 or 10 plus 15 plus 7. Let's go ahead and add that up. That's 25, 26, 27, 28, 29, 30, 31, 32. That's 32 miles one way to go round trip. That is this way once, this way back. We have to multiply it by 2, so that's going to be 4, 6. So we traveled a total distance of 64 miles. Okay? And again, we know this is 1 mile equals 10 miles, so we're just going to add a 0 onto that. So we traveled a distance of 240 miles. Again, these are inches, so this should have been 64 inches, which is 640 miles. Okay? You get 28 miles per gallon, and gas cost $2.73 per gallon. How much did you spend? Okay? So we got to take this 640 divided by 28. This is going to give us how many tanks of fuel we used, and then we'll multiply that by 273. Okay, so we need to say how much are 28 times what gives us 64, or what gets us closest to 64. Let's try 2, and if not, we'll drop down to 1. This is 8 times 2 is 6, carry the 1. 2 times 2 is 4, plus 1 is 5, so this is going to be 2. It's going to be 56. Subtract it. 64 minus 56 is going to be, let's see, we're going to have to borrow 10 from there. This is going to become a 5. This is going to become 14. That's going to be what? 6 plus 6 is 12. 6 plus 8 will get you 14. 5 minus 5, 0. Drop down this 0. So now we're saying to ourselves, 28 times what will give us 80 or closest to 80? Well, 30 times 2 will give you 60. 30 times 3 will give you 90. So if we were to do 28 times 3, that would probably put us over. Let's just confirm that. 8 times 3 is 24. 2 times 3 is 6, plus 4 is 84. That puts us over, so we're going to have to do another 2 there. And we know that's going to get us 56. So 2 times 28 is 56. Subtract this out. This drops down to 7. This becomes a 10. This is 4. 7 minus 5 is 2. And we drop down an imaginary 0 because we're going to need it. Okay. And now we're actually going to be working on decimals here. So we're at 28 times what will get us close to 240? Well, 30 times 7 would get us 21. 30 times 8 would get us 240. So let's go with 28 times 8. 8 times 8 is 64. 8 times 2 is 16. Plus 6 is 22. So this actually gets us 224. Subtract. So we know this is going to be 0.8. Let's go ahead and take it to another decimal place, and then we'll stop and round, because as long as we got one decimal place, we know our answer is not going to be way off. We can't take away 0 from 4, so let's make this as 3 and this a 10. It's going to be 6. This is going to be 1. So 2 minus 2 is 0. Let's bring down another 0. 28 goes into 160. Well, 28 times, or 30 times 5 would get us 150. So let's go with 5. So we know this number is, if we round it, is going to be 22.9. Okay? And again, I'm just rounding to one decimal place. When you round, if it's a 5 here or greater, it kicks this up to the next digit. If it's a 4 or later or lower, you would just leave it as the 8. So now we know how many tanks of fuel it takes to go the 640 miles round trip. Let's take 22.9 and multiply it by 2.73 $. Let's move our decimals to make the math easy. 1, 2, and 1. So we moved it 2 here, 1 here, a total of 3. I'm going to rewrite it just so I don't make mistakes. This is 273 times 22.9 or 229. Again, we're working with 3-digit multiplication. Take your time. You can make mistakes pretty easily. And again, we moved it 3 decimal places, so we'll have to add those back in at the end. 9 times 3 is 27. Carry the 2. 9 times 7 is 63. 64, 65. Carry the 6. 9 times 8 is 18. Plus 6. 18, 19, 20, 21, 22, 23, 24. Bring down a 0. 2 times 3 is 6. 2 times 7 is 14. Carry the 1. 2 times 2 is 4. Add 1 is 5. Add 2 zeros now since we're working with the 3rd digit. 2 times 3 is 6. 2 times 7 is 14. Carry the 1. Again, that's going to be 5. Add it up. 0 plus 7 is 7. 5 plus 6 plus 0 is 11. Carry the 1. 6 plus 4 is 10. Plus 4 plus 1 is 15. Carry the 1. 5 plus 4 is 9. Plus 1 is 10. Plus 2 is 5 plus 4 is 9. Plus 1 is 10. Plus 2 is 12. Carry the 1. So this is going to be 62.517. I must have made a mistake somewhere, but the answer fairly obviously is going to be 62.14. Let me just grab a calculator to check my work. Okay, so I'm confident about the 640. Let's go ahead and check my math here. 640 divided by 28, 22.85, which I got right. I rounded it to 22.9, and I multiplied that by 2.73, which should give us 62.51. Let me check my math up here. 10 plus 7 plus 15. 32 times 2. That's 640 times 10. 640. We know it's 28 miles per gallon. Okay. 22.857. Let's not round it this time, and let's just multiply this by 2.73. Gets us 62.4. Okay. So in other words, they used a different rounding than we did. This 62.5 is different than 62.41 because of a rounding error. They should have told you to round to a specific number here, which I did not do. So we actually did this correct. And in the real ASVAB, you're going to see that sometimes these problems get very tedious, and sometimes you choose to round one way, but they rounded another way. As long as you're confident with your math and you get something close, you can chalk up the difference to a rounding error, which is what happened in this case. The smoke detector in your house has a malfunction and beeps every 5 minutes. If it first beeps at 10 p.m., how many times will it beep by 4 a.m. when you finally give up and take a hammer to it? So first, let's go from 10 to 4 and count how many hours that is. So we go 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, and 3 to 4. That's 1, 2, 3, 4, 5, 6 hours. Okay, so you finally smashed your alarm clock or smoke detector after 6 hours. Every 5 minutes it beeps. How many times does it beep in 6 hours? So we have this in hours and this in minutes. Let's make sure our question we're working with the same units. So 6 hours is the same as 6 times 60 minutes. Again, there are 60 minutes an hour. So 0 times 6 is 0. 6 times 6 is 36. There are 360 minutes in 6 hours. Those are equivalent. We know it's beeping every 5 minutes, so let's take this 360 divided by 5 to find out how many times it beeps total. 5 doesn't go into 36 or 3, but it does go into 36 7 times. 7 times 5, of course, is 35. Subtract that out. 36 minus 35 is 1. Bring down this 0. Just drag it down. 5 goes into 10, of course, just twice. So over the course of 6 hours or 360 minutes, it's going to beep 72 times. A display is selling bunches of bananas. A display selling bunches of bananas contains 6 dozen banana bunches when the display is full. The manager of the produce department is supposed to make sure the display is restocked when it is 1/4 full. How many bunches of bananas will be on display when it's time to restock? So we know there's 6 dozen bunches. So in other words, there's 12 times 6 bunches, which we just saw in the last problem is 72 total bunches. The manager has to restock when it reaches 1/4 full. So 72 times 1/4 will get us that number. 72 can be thought of 72 over 1. When you multiply fractions, you multiply straight across. So you get 72 over 4 when you multiply straight across, which is the same as 72 divided by 4. 72 going to 7 just once. 4 times 1 is 4. Subtract 3, and you bring down the 2. 4 goes into 32, of course, 18 times. So the manager will restock when there's 1/4 or 18 banana bunches on display. Ron and Joy own a condo together. They decide to sell for $200,000. The two decide to split the proceeds according to the ratio of money each invested into the property. Rod put the most money at a ratio of 5 to 3. How much money should Joy get from this sale? Okay. So this one's tricky. You have to know how to set these problems up to get them right. We know the ratio is 5 to 3. We're given that. But what does that mean in terms of setting up this problem? If I were to do 5 over 3 equals x over 2,000 or 200,000, I'd be thinking on the right track, but this ratio does not hold true. This says 5/3 equals x over 200,000, which is not what we're looking for. To think about this one a little better, let's add these two. 5 plus 3 is 8. So we know Joy's share is going to be 3 to 8, whereas Rod's share is going to be 5 to 8. And when you think about that, when you add those two together, that's a total share of 8 to 8. Okay? Again, this is Joy here, so using 3 over 8 equals x over 200,000. Now we can find the right answer. Again, you're on the right track here, but you had to think about it in this way. So let's go ahead and do that. We cross multiply in this case. That gives us 8x equals 600,000. So let's go ahead and work this out. 600,000 divided by 8. 8 does not go into 6, but 8 goes into 60, I believe, let's say 7 times. Okay, and it goes in 8 times 7 is going to be 56. Subtract that out. 60 minus 56 is 4, and we just drag down these zeros. So we have 1 0, 2 0, 3 0, 4 zeros. 8 doesn't go into 4. 8 goes into 40 5 times. 8 goes into 40,000 5,000 times. Okay? Subtract that out. We can see there's no remainder. So as far as Joy is concerned, she's going to get a share of $75,000. That's directly proportional to the deal they made and the amount they invested. On a trip, you drive 350 miles at an average speed of 60 miles per hour. Then you return home driving an average speed of 70 miles per hour. How long did it take you to complete the trip? Again, it's asking you how long. It's giving you a rate, but not the distance. So we're going to be working again with a distance equals rate times time problem. Let's sketch it out to see if it makes sense. What does give us the distance and rate? We don't know the time. We know leaving, we go 350 miles and we travel 60 miles per hour, and coming home going the same distance we go 70 miles per hour. So you can do this of one of two ways. You can either combine the problems, or you can just do them separately. That is, you can solve this DRT problem and then this DRT problem and then add them together, and that, it turns out, is the simplest way to do it. So for the first one, we know we went a distance of 350 miles. We know we traveled at 60 miles per hour. We don't know how long this first trip took, so let's go ahead and solve for t in this case, and this is an equal sign. To get t by itself, we first subtract both sides by 60. So that gives us t equals 350 divided by 60. To make this math easier, I'm going to kick off these zeros and I'm going to do the long division. 35 divided by 6. 6 does not go into 3, but 6 goes into 35. 6 times 6 is 36. 6 times 5 is 30. So we're going to subtract 30 away. 35 minus 30 is 5. Carry down a 0. 6 goes into 50. 6 goes into 50, not 10 times. 6 times 10 is 60. 6 times 8 is 48. Okay. So let's go ahead and subtract that out. That's going to be 2. Bring down a 50 minus 48 is 2. Bring down an imaginary 0. 6 goes into 23 times. 6 times 3 is 18. Subtract that. 18 minus 20 is 2. Carry down a 0. And so this is just going to repeat. So we can actually round this to 5.8 hours. The first trip takes us approximately 5.8 hours. Let's go ahead and work out this second trip. Hopefully it works out as a whole number. Again, we know we're going a distance of 350 miles. We're traveling 70 miles per hour. We don't know how long it's going to take. Okay. Again, to get t by itself, we divide both sides by 70. This goes away. This becomes, if you look at it, 35 divided by 7. 35 divided by 7 is just 5. So we know t in this case is 5 hours. So we have 5.8 hours and 5 hours, which is going to be 10 point something hours. It's not going to be, it's going to be 10.8 hours. Okay? And we're done. Again, we work both problems separately, and then at the end just combine the hours together, and we were done. Okay, an empty 50-gallon barrel weighs 35 pounds. When completely filled with water, the barrel weighs 455 pounds. Assuming these factors to be true, approximately how much does 1 gallon of water weigh? So we got some barrel that looks like this. Let's imagine it's a steel barrel. We know that when it's empty, the steel barrel weighs 35 pounds. So that should be a B. So the steel, or the barrel itself, weighs 35 pounds. With 50 gallons of water, it weighs 455 pounds. How much does each gallon weigh? Well, first we got to subtract out this weight of the barrel. Okay? So 455 minus 35, 5 minus 5, 0, 5 minus 3 is 2. Still left with a 4 there. So the weight of the water inside this barrel is 420 pounds. We know there are 50 gallons of water, but we want to find out how much 1 gallon weighs. So we're going to take 420 and divide it by 50. To keep the math simple, we're going to kick off these zeros. 5 goes into 4. It doesn't. 5 goes into 42 8 times. Take a look. We can already stop if we wanted to, but let's keep working. 8 times 5 is 40. Subtract. Again, since we're going past that, we're going to need to drop a decimal in our answer. 42 minus 40 is 2, of course. Add a 0 down. 5 goes into 24 times, 8.4 pounds. If you're traveling in a car, traveling 50 miles per hour, how far have you traveled in 45 minutes? Again, we're given rate, 50 miles per hour, time, 45 minutes, and we want to know the distance. So again, this is a DRT problem. Distance equals rate times time. And at the beginning of this video, I warned you, if something's in miles per hour and you're given minutes, you need to convert those minutes to hours to get the problem correct. In other words, you have to keep miles per hour with hours. If this said miles per minute, you would be fine. But since this says miles per hour, we need to convert this to hours. Okay, so let's go ahead and do that. 45 minutes. How many hours is that? Well, we know there's 60 minutes in an hour. Okay. And we can reduce this. 45 or 15 goes into 45 3 times. 15 goes into 60 4 times. So 45 minutes is 3/4 of an hour. Okay. So now we can use this number and plug it in our formula to find our distance. So distance unknown equals 50 times 3/4. Okay, let's go ahead and do this math. 50 times 3/4 is the same as 50 over 1 times 3/4. Multiply straight across. This is the same as 150 over 4. are the same as 75 divided by 2. Let's go ahead and work that out, but it should be fairly obvious that it's going to be 37.5. 75 divided by 2. 2 goes into 7 3 times without going over. 2 times 3 is 6. 7 minus 6 is 1. Bring down our 5. 2 goes into 15 7 times without going over. 2 times 7, of course, is 14. Subtract. That's 1. We're going to drop down a 0. 2 goes into 10 5 times. So 37.5 miles per hour. Okay. If an average person eats 6.7 pounds of French fries per year, how much would that average person consume in a decade? There are 10 years in a decade, so this problem becomes 6.7 times 10. And since I've been showing you how to do multiplication with decimals, move this over 1, add it back in at the end. So 7 times 0 is 0. 6 times 0 is 0. Bring down a 0 since we're starting a new row. 7 times 1 is 7. 7 times 6 is 6. Add. 0 plus 0 is 0. 0 plus 7 is 7. 0 plus 6 is 6. And bring back in our 1 decimal. And the answer is 67 pounds. Okay. Maloney has 11 more nickels than quarters. How many quarters does she have if the total value of her coins is 265? These problems, it turns out, are very tricky. We know a nickel is worth 5 cents, which is 0.05, and we know a quarter is worth 0.25. Okay. We don't know how many quarters or nickels there are total, so let's represent the unknown as an x, but we know combined there's a total of $2.65. We're given this little tidbit of information that kind of throws us for a loop initially. Maloney has 11 more nickels than quarters. So we kind of got to work that into our equation or deal with it before we can work anything out. What I'm going to do is the easiest way to work this problem. So we know this would get us the number of nickels and quarters there are total, excluding the 11, right? To address the 11, let's just get rid of those out of the total right away. We know there's at least 11 nickels in this pile. So 11 times 0.05. Okay, move it 2 decimal places to give you just 5. Let's rewrite it to make it nice. 11 times 5. 1 times 5 is 5. 1 times 5 is 5. Throw your 2 decimal places back in. 1, 2. So we know at the very minimum there's going to be 55 cents in nickels that are extra. So let's go ahead and take that away from our 265. So we don't have to worry about them when we work this problem out. 265 minus 0.55. 5 minus 5 is 0. 6 minus 5 is 1. Bring down your decimal, 2. So now let's rewrite this, excluding the 11 nickels that we're not worried about. 0.05x plus 0.25x equals 2.10. Okay, let's solve for x. 0.05 plus 0.25 is 0.30x equals 210. Oh, I don't know why I put an 8 there. Now let's think about this. 0.3 or 30 cents into 210. That is actually going to be, x is going to be 70. You don't really have to do the math. 7 times 3 is 21. 7 times 30 will get you 210. So we know that, oh, it's just going to be 7. Not 70, why did I put that? So 7 times 30 will get you 210. So 7 times 0.3 will get you 2.10. Okay. Again, X represents the number of quarters and nickels. So let's see where we're going from here. We're going to say X represents the number of quarters that are in the pile. So if there are 7 quarters, there are 11 more nickels. So 7 plus 11 is going to be 18. And let's work that out. So if there are 7 quarters, that's 6 quarters would be $1.50. 7 would be $1.75. And that means there are 18 nickels. 18 times 0.05. 8 times 5, of course, is in 2 decimal places to make this just 5. 8 times 5 is 40. Bring over our 4. 5 times 1 is 5 plus 4 is 9. Bring over 2 decimals. 175 plus 90. Let's see if that adds to 265. Five plus 0 is 5. 7 plus 9 is 6. Carry the 1. 1 plus 1 is 2. Okay, so we know this represents the number of quarters, whereas this represents the number of nickels, so the answer is C. A little confusing there, but I think you, at the end of the day, will get these problems. And on that note, that's all I have for you. If you have questions, concerns, or comments, feel free to put those in the comments section below or to send me a private message. But apart from that, I am going to cut you guys loose. Konnichiwa.